Python counter module. In this lecture, we'll learn about counters, different ways to initialize them, updating them, accessing counts, reassigning counts, and counter arithmetic. A counter keeps track of the number of times a value appears in a container. Such a value is a hashable object. Such an object has a hash value that does not change during its lifetime and can be compared to other objects. This is a subclass of the class date. Let's import it from the collections module. We create an object of counter to which we provide a list and call this count. This creates this counter object with the counts of these values. In that list, A appears thrice, B twice, and C only once. This stores the items as dictionary keys and their counts as their values. This means we can access a value indexing by the key. A appears thrice here. The dictionary is in descending order of the counts or values. There are many ways you can initialize a counter with the counter factory function. Such a function helps dynamically create an object on the user's request. One example is when the user opens the browser. Each tab is an object generated at the user's request. Let's use a list. We've seen this one. A comes thrice, B twice, and C once. We can also use other containers like tuples, strings, and sets. Let's use a dictionary to initialize this. We can also use keyword arguments to do this. Here, we declare the counts for A, B, and C to be 3, 2, and 1 respectively. Now, if we create an empty counter object, we can populate it later. We create an empty object, put the string hello in it with the update method, and print it. We have 2 L's, 1 H, 1 E, and 1 O. Here, we create an empty counter object and then update it with the dictionary E2 and O4. When we print it, we increment the counts for O and E by 4 and 2. They are now 5 and 3. Since this gives us a dictionary, we can access it indexing it with a key, which is the element to count. Count hello of E is 3. Let's build a for loop to print the counts from count hello for each letter in the string help. H appears once in hello, E appears once, L appears twice, and there's no P. But this is not a key error and simply returns a count of 0. We can also display counts using the elements method. This returns an iterator object for the values in the counter. This is a counter we call count1. For each item in count1.elements, print it and its count. So it prints the items and their counts. It does not print it for D because that has a count of 0. We can check this by iterating on the items in the iterator object returned by the elements method. The end part is to strip the new line character from each print statement and keep it all in one line. But since a counter counts values, it also lets us access the n most common values. The 2 most common values are A and B in order. The 4 most common are A, B, C, and D. Without an argument, the most common method returns all items and their frequencies, but in descending order. Counts are mutable. Simply by indexing with a key, we can reassign the count for it. Let's set the count of E to 5. We can also clear a counter to rob it of all its keys and values and empty it. Unlike plain dictionaries, you can add or subtract counter objects. Well, it just makes sense. You may need to add the counts for some reason. This is basic counter arithmetic. We have 2 counter objects 1 and 2. Adding them adds their counts for common items and displays the counts for all items from both objects. C is common here, so its count becomes 4. Subtracting 2 from 1 subtracts the counts of 2 from those of 1. A and B are not affected. C had a count of 1. This is now 0, and D and E already did not exist in 1. And 2 minus 1? By the same logic, we have the result. Let's try some more operations. If we subtract 2 from 1, we also get negative counts. And if we add 2 to 1 now, we restore the original state of 1. 1 bitwise and 2 leaves us with only C. 1 bitwise or 2 gives us the union of the two. Notice that the count for C here is 3 and not 4. Let's define a third object 3. Negative of this means the values become negative of what they are. Minus 1 becomes 1 and 3 becomes minus 3. The counter module in Python lets us count how many times an item appears in a collection.